Stop scrolling. Everything you think you know about galaxies is about to change. Right now, 53 million light-years away, there's a monster lurking in space that makes our entire Milky Way look like a speck of dust. And here's what nobody tells you. It's not alone. The Virgo cluster contains over 1,300 galaxies packed into a cosmic neighborhood. And the true rulers there aren't the beautiful spirals you see in textbooks. They're the giants, the ellipticals. And the king of them all is Messier 87, a galaxy so massive it could swallow 200 Milky Ways and still have room for dessert. But here's where it gets controversial. Scientists have been lying to you about what galaxies really look like. Well, not lying exactly, but definitely showing you favorites. Pick up any astronomy book, and what do you see? Gorgeous spiral galaxies with elegant arms, stars arranged in perfect cosmic pinwheels. The Milky Way, Andromeda. Beautiful, right? Here's the truth. Most galaxies in the universe don't look like that at all. In fact, in massive galaxy clusters like Virgo, giant elliptical galaxies completely dominate. These aren't your Instagram-worthy space photos. They're featureless, blob-like spheres of ancient stars. And they're absolutely terrifying in scale. Messier 87 stretches across 240,000 light-years. Our Milky Way, a mere 100,000 light-years. This giant contains approximately 1 trillion stars compared to our paltry 200 to 400 billion. But wait, there's something even more mind-blowing. M87 is essentially a graveyard. Most of its stars are old, red, and dying. There's very little new star formation happening. It's like a cosmic retirement home, but one that could gravitationally bully every galaxy in its vicinity. And bully it does. The Virgo cluster isn't some peaceful cosmic community. It's a battlefield where galaxies are being ripped apart, cannibalized, and merged into these elliptical monsters. Scientists now believe that's exactly how giants like M87 got so big. They ate their neighbors. Literally. Through a process called galactic cannibalism, larger ellipticals consume smaller galaxies, growing more massive over billions of years. Here's what shocked researchers. In 2019, the Event Horizon Telescope collaboration released the first-ever image of a black hole. Guess where it was? Right in the heart of Messier 87. This black hole weighs 6.5 billion times the mass of our Sun's 6.5 billion. To put that in perspective, if our Sun were a marble, this black hole would be larger than Earth's entire orbit. And it's shooting out a jet of superheated plasma 5,000 light-years into space at nearly the speed of light. But let's interrupt this cosmic horror show with an uncomfortable question. Why do we have giant ellipticals in clusters, but rarely in isolated regions of space? The answer reveals something deeply unsettling about the universe's violence. Elliptical galaxies are trauma survivors. They form primarily through galaxy collisions and mergers. In dense environments like the Virgo cluster, where galaxies are packed relatively close together, collisions are common. When two spiral galaxies collide, their beautiful arms get destroyed, their gas gets used up or stripped away, and what remains is this featureless elliptical shape. The Virgo cluster is so dense that it contains about 160 trillion solar masses worth of material in a space that, cosmically speaking, is incredibly compact. Now here's where your mind should explode. Our Milky Way is being pulled toward the Virgo cluster right now at approximately 1,000 kilometers per second. We're part of what's called the local group, and our entire local group is falling toward this massive collection of galaxies. Don't worry, we won't reach it for billions of years, but the gravitational influence of the Virgo cluster affects us even from 53 million light-years away. The controversy in the scientific community? For decades, astronomers debated whether elliptical galaxies were simply born that way or created through mergers. The merger theory has now won, backed by computer simulations and observations. But here's what's uncomfortable. This means the beautiful spiral structure of galaxies is temporary. It's fragile. In the chaotic environments of galaxy clusters, spirals are destroyed and ellipticals reign supreme. The universe doesn't preserve beauty. It rewards mass and gravity. Messier 87 isn't just massive. It's surrounded by approximately 15,000 globular clusters. Our Milky Way has around 150 to 200. Each of these globular clusters contains hundreds of thousands of ancient stars. M87's halo extends so far that it overlaps with neighboring galaxies, making it hard to determine where one galaxy ends and another begins. The Virgo cluster also contains other notable giant ellipticals: Messier 86, Messier 84, and Messier 49. Together, these galaxies create a gravitational environment so intense that they've stripped smaller galaxies of their gas, preventing new star formation. They're cosmic bullies, and the Virgo cluster is their playground. What makes this relevant to you? Understanding galaxy evolution helps us predict the future. In about 4.5 billion years, the Milky Way will collide with Andromeda. The result? Likely a giant elliptical galaxy. Our descendants, if humanity survives that long, won't live in a beautiful spiral. They'll inhabit a featureless elliptical, probably orbiting a merged supermassive black hole. The Virgo cluster gives us a window into both the past and future of galactic evolution. It shows us what happens when gravity wins, when galaxies cluster together, and when the universe's violence shapes cosmic architecture over billions of years. If you've made it this far, you're clearly curious about the universe's most fascinating secrets. Follow us for more mind-bending space facts that textbooks won't tell you. Now here's my question for you. If our Milky Way is destined to become a giant elliptical galaxy after merging with Andromeda, does that make our current spiral structure more precious? Or does it simply mean we're witnessing one temporary phase of an endless cosmic cycle?